Lesson 9.3, Quadratic Inequalities in two variables. The solution to quadratic inequalities in two variables is any coordinate that will satisfy the inequality. Follow the same steps to solving linear inequalities, only graph quadratics instead. And our solution region will be either shaded inside the quadratic or outside the quadratic. First example, graph y is greater than x minus 4 squared minus 2. Just a reminder, this would be in what form of a quadratic? It would be in vertex form. So we know that our vertex comes from these two values. Our vertex would be the x values opposite of what it looks like in the function, so it would be positive 4. The y value is exactly the same as how it looks in the equation or the inequality, so negative 2. We can, if we want to find our y-intercept algebraically, we can multiply out the binomial and then combine like terms. Y is greater than x minus 4 times x minus 4 minus 2. Multiply the two binomials. Y is greater than x times x is x squared, x times negative 4, negative 4x, negative 4 times x, negative 4x, negative 4 times negative 4, positive 16 minus 2. Y is greater than x squared minus 8x plus 14, and 14 would be our y-intercept, the constant term of the quadratic in standard form. Now that we have the vertex and the y-intercept, we can sketch a quick graph of our quadratic. Let's say here is 4 and 2, 4, 6, 8, 10, 12, 14, 2, 4, so 4 and negative 2, and then 2, 4, 6, 8, 10, 12, 14 is there. And then we have to decide, like with the linear inequalities, do we have a solid line or do we have a dotted line? So we have an inequality that does not include the equal sign, which means we have a dotted line. We know that if we have a point, the point 0, 14, the y-intercept, that is 4 units left and 16 units up from the vertex. Because parabolas are symmetrical, then we must also have a point that is 4 units to the right and 16 units up from the vertex. So that would be at x equals 8 and y equals 14. And then using a dotted line, we can join our 3 points together to create our parabola. And there is our parabola for this inequality. We need to do some test points. We're going to test a point that's inside the parabola, and we're going to test a point that is outside the parabola. So I'm going to pick some easy points here. 0, 0, if I can see that it's definitely on one side or the other, is a good one to pick. So 0, 0, I want to test that. I'm going to sub it into our inequality. Y, which is 0, is greater than x, which is 0 minus 4 squared minus 2. 0 is greater than negative 4 squared minus 2. 0 is greater than negative 4 squared is 16 minus 2. 0 is greater than 14. Is that true? No. 0 is not greater than 14. Then I want to pick another test point. So I'm going to go at my axis of symmetry where x equals 4, and then I'm just going to go up a bit. So maybe I go to y equals 6. 4 and 6. So that's a point right in the middle of my parabola, so I know it's inside there. Let's test that point. 4, 6. Y, which is 6, is greater than x, which is 4 minus 4 squared minus 2. 6 is greater than 4 minus 4 is 0, so that's gone. So if 6 is greater than negative 2, is that true? Yes, 6 is greater than negative 2. So this tells me to shade inside the parabola. Okay, so that's my solution region, is anywhere in that shaded region. I can pick any point that's in there, and that would be a solution to the system. Next example, graph y is less than or equal to x squared plus 2x plus 4. We have an equal sign with our inequality, so this means it's going to be a solid line. This quadratic is in standard form, which means my c value, my constant term, is the y-intercept. As for other points, I can use my graphing calculator to help me draw the graph, unless it says to do everything algebraically, but it doesn't. So let's use graphing calculator to graph the quadratic y equals x squared plus 2x plus 4, and then we can use our test points to graph the inequality. Going to our graphing calculator, going to y equals, clearing whatever's in there. We want to enter, it's already in standard form with the y on the left hand side, so that's good. We want to go x squared plus 2x plus 4, and then graph it. Now my windows are odd from previous, so I'm going to go zoom standard back to plus 10 minus 10 for x and y. So I get this image here. I'm going to draw a quick graph, or a quick sketch of my graph. We've got a y-intercept at 4. Let's say it's about here. And then let's find our minimum, second trace 3. We need to be left bound. Put my dot somewhere left of the minimum, hit enter, move my dot to the right side of the minimum, hit enter, and negative 1 and 3. Negative 1 and 3. So we'll say it's about there. And then because it's symmetrical, we would have a point at negative 2, 4. And as we said, it has a solid line. There's my parabola. Let's do some test points. We want to test the point that's inside the parabola, and we want to test the point that's outside the parabola. Testing a point on the inside, or testing, let's test the point on the outside first. This is easy one. The point 0, 0. plug it in. Y is 0, less than or equal to 0 squared plus 2 times 0 plus 4. That's 0, that's 0. We have 0 is less than or equal to 4. That's a true statement. 0 is less than or equal to 4. So this would indicate that we would shade outside. Let's test the point inside just to make sure. So I'm going to go to my vertex at -1, and maybe I'll test the point -1, 5. Subbing in, we have 5 is less than or equal to -1 in brackets squared plus 2 times -1 plus 4. Simplifying, -1 squared is 1, 2 times -1 is -2, plus 4. 5 is less than or equal to 5, take away 2 is 3. Is 5 less than or equal to 3? No, it is not. So we see that this says shade outside the parabola. So our solutions are any coordinate points outside that parabola. A satellite dish is 60 centimeters in diameter and 20 centimeters deep. The dish has a parabolic cross-section. Determine an inequality that shows the region from which the dish can receive a signal. Let's draw a quick sketch. We know that it is 20 centimeters deep and 60 centimeters in diameter. 30, 60. So it would be our center. So we can draw our parabola. In this case, our satellite dish. We want to determine the inequality that shows the region from which the dish can receive a signal. Well, the dish is going to receive a signal inside the dish, so inside the parabola, which means it's going to be anywhere in here is our solution region. What we want to do is first find the quadratic equation that represents the satellite dish and then second we want to find the inequality sign for the solution region. Okay, so this was our diameter in centimeters, and this was our depth in centimeters. Let's find an equation for the parabola first. Y equals, using vertex form because we know the vertex, because we have our y-intercept would be at 0, 20. This point over here would be at 60, 20. Our vertex is halfway between those for the x value, so 30, and it's at 0. So 30, 0. Okay, so we're going to use vertex form, y equals a bracket x minus p close bracket squared plus q. Subbing in our vertex, y equals a bracket x minus the x value of the vertex is 30 squared plus the y value of the vertex is 0. I don't actually need to write that, plus 0. So then we want to sub in another point for x and y, because we can only have one variable if we're going to solve for that variable. So plug in either 0, 20 or 60, 20 for x and y. I'm going to go with 0, 20. So y is 20 equals a bracket x is 0 minus 30 squared. Then I want to solve for a. 20 equals a. Let's bring up our calculator. We want to go to our main screen, and we have negative 30 squared bracket negative 30 close bracket squared. Okay, I don't know where that was. Negative 30 close bracket squared. Enter, we get 900. So a times 900. We want to then divide by 900 on both sides. And then if we go 20 divided by 900, enter, math, enter, enter, we get 1 over 45 equals to a. Then we can write our equation, go back to this one, and we get y equals, we want to replace the a, 1 over 45 bracket x minus 30 squared. There's our equation. Now we need to do number 2. So that was part 1. Now we want to do part 2. We already know what our solution region is. We know that it's inside our parabola or inside our satellite dish. So we are going to use a point from the shaded region to determine the inequality sign. So a point that is inside the shaded region, we could pick the point, if we go to 30 and go up halfway, so x equals 30, y equals 10. That is definitely inside the shaded region. I can write the statement, the inequality must be true for the point 30, 10. What I do next is I sub in the point 30, 10, but instead of having an equal sign or an inequality sign, I just put a box because I'm not sure what the sign should be. Y, which is 10, and then our symbol, which we don't know what it is, 1 over 45 bracket x, which is 30 minus 30 squared. Then we want to just simplify this and see what inequality we should have. 10, unsure of our inequality sign, 45, 30 minus 30 is 0, and 0 squared is 0, times anything is just 0. We are left with 10 something 0. So is 10 less than 0, greater than 0? It is greater than 0. And with word problems like this, you can say greater than equals to or just greater than. I would accept either answer. Therefore, our inequality becomes y is greater than or equal to, or just greater than, 1 over 45 bracket x minus 30 close bracket squared. Climbing rope can safely support mass m in pounds, modeled by m is less than or equal to 1240 d minus 2 squared, where d is the diameter of the rope in inches. Graph the inequality to examine how the mass that the rope supports is related to the diameter of the rope. Let's look at our inequality. M is less than or equal to 1240 d minus 2 squared. Our inequality sign has an equal sign that tells us we are graphing with a solid line. Our quadratic is in vertex form. We can just add a 0 here. Then our vertex is x value is opposite, so positive 2, y value is the same, 0. That's our vertex. And we can use our graphing calculator to help us draw a sketch of the graph if we like, or we could calculate our y-intercept, but it's going to be a pretty big number since our a value is quite large. So use calc to help graph. Let's do that. Y equals, clear what's in there, enter the equation y equals 1240 bracket x minus 2 close bracket squared. Graph that. We see a weird looking line. What that means, the reason it's like thick, is because that's our whole parabola. So we want to zoom in on that. Zoom, we can try 6, zoom fit. There we go, that's a better graph. And if I just look at my numbers here, they're quite big, 73,000, quite large numbers. So I'm gonna go to my window, just for graphing purposes. I'm gonna go 0 for my x min, because thinking about this situation, x represents diameter in this case. Diameter can't be a negative. So I'm gonna go 0, and I'll stick with 10 for my max, and oops. Okay, I enter, oh, undefined. It's not currently defined. Exit, window, 0, 10, min is 10, max, min, clear that. I'm gonna go 0 for my y min, and I'm going to go to our our a value is 1240. I'm just going to try 1,000 for my y max, and I'm going to go up by hundreds for my scale. And let's see, there we go. Okay, so that's a decent picture. I can do a little sketch of this. Doesn't have to be perfect, just a sketch. So down here we would have diameter, and that's in inches. And most of our information here is 1, 2, 3. Our vertex is at 2, 0. The y-axis is going up to 1,000, and that is for mass in pounds. And then our graph looks something like this. It's quite slim. Okay, something like that. Now we need to figure out which part is going to be shaded. So the next step is to do our test points. We need to test the point inside and test the point that is outside. So I'm going to test the point, let's test the point 3, this would be like 100. Let's test the point 3, 100 for our outside point, and I'll test the point 2, 100 for my inside point. I'm going to do the inside first, doesn't matter. 2, 100. I have 100 is less than or equal to 1240 times 2 minus 2 squared. Calculate 100 is less than or equal to, 1240, 2 minus 2 is 0, 0 squared is 0, so that whole thing is going to be 0. Is 100 less than or equal to 0? Nope, it's not. Let's do the next point. 3, 100. 100 is less than or equal to 1240. 3 minus 2 squared. 100 is less than or equal to 3 minus 2 is 1, squared is 1, so 1240. Is 100 less than or equal to 1240? Yes. So we would shade outside. Our parabola. Okay, so we would shade all around the outside of the parabola. There's our graph. That brings us to the end of Chapter 9, Lesson 2, solving quadratic inequalities in two variables.